Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one numerical example to make you understand the paging concept in detail. So I request everyone to watch the complete video for better understanding. They have given main memory size is 32 bytes, process size is 4 bytes, page size is 2 bytes. If page size is 2 bytes, obviously the frame size will be 2 bytes. So main memory is nothing but physical address space. So the physical address space is 32 bytes. So physical address will be how many bits? If it is byte addressable format, if you have 32 bytes, meaning is that you have 32 combinations. If you have 32 combinations, then 32 can be represented as 2 power 5. So in physical address, you have totally 5 bits are there. Similarly, the process size they have given it as 4 bytes. So logical address space is equal to 4 bytes. Then logical address will consist of how many bits? As it is a byte addressable format, you have 4 combinations. 4 combinations can be represented as 2 power 2. So you have 2 bits. Okay, are you able to understand? And the process size and frame size they have given us 2 bytes. Now first thing we need to find the physical address. The physical address is consists of 2 parts. One is the number of frames, meaning is that frame number, and frame offset. Logical address will consist of page number and page offset. So let's consider that as the main memory is 32 bytes, first we need to find number of frames. The number of frames in the main memory is equal to size of main memory by size of frame. Okay, are you able to understand? What is the size of main memory in this example? 32 bytes, and size of a frame is 2 bytes. So you will have totally 16 frames are there. Okay, so number of frames is equal to 16. Similarly, we will compute the number of pages. Number of pages is equal to size of process by size of a page. Okay, size of page. Now look at what is the process size is 4 bytes and page size is 2 bytes. So 4 by 2 is equal to 2. So number of pages is equal to 2. Okay. Now we will further split up the physical address. The physical address is divided into 2 parts. One is the frame number and another one is the frame offset. Okay. In physical address, we will have frame number and frame offset. The frame offset will depend on the size of the frame, and frame number will be depend on the number of frames. Is it clear? Now if you look at the frame offset or the frame size is 2 bytes. Okay, are you able to understand? As it is a byte addressable format, if you have a frame size of 2 bytes, then you need 1 bit to represent the frame offset, because 2 can be represented as 2 power 1. So you need 2 bytes, so you need 1 bit. So 1 bit is for the frame offset. If total physical address size is 5 bits, your frame offset is 1 bit, then you will have 4 bits for the frame number. How we can get it? You can cross check like this also. Number of frames is equal to 16. If number of frames are 16, 16 can be represented as 2 power 4. So you need 4 bits. Now you can ask me how you got it. Suppose let's take that if you have 2 bits and each bit can be either 0 or 1, then how many combinations you can get? 4 combinations such as 0, 0, 0, 1, 1, 0, 1, 1. Similarly, let's take that if you have 3 bits and each bit can be represented either 0 or 1, then you will have 8 combinations. One is 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. So similarly, if you have 4 bits and each bit can be either 0 or 1, then you can generate 16 combinations. So physical address is totally 5 bits and number of frames is 16 frames. So frame number will occupy 4 bits and frame offset will occupy 1 bit. Is it clear? And coming to the logical address is divided into page number and page offset. Okay, now page offset will depend on the page size. As the page size is 2 bytes and it is a byte addressable format, 2 can be represented as 2 power 1, so you need 1 bit. Or you can remember one thing, as the page size and frame size is same, so the number of bits occupied for the frames offset will be equal to page offset. And as the total address of the logical address is 2 bits, 1 bit is occupied for the page offset, then how many bits will be there for the page number? Obviously 1. If you want to cross verify, you can verify. Number of pages is 2. If you have 2 pages, then 2 can be represented as 2 power 1, so you need 1 bit only. So if it is 1 bit, it can be either 0 or 1. If it is 0, then it represents page number 0. If it 1, it represents the page number 1. Is it clear? So 1 bit for the page number, 1 bit for the page offset. Is it clear? Now we will discuss the further things. Now as the main memory is divided into 16 frames, let me represent that 16 frames for your better understanding. Okay, frame number 0, frame number 1, frame number 2, frame number 3, frame number 4, 5 up to 15 I will write. Let me 6, 7, 8. I hope you are following with me. Okay, 9, 10, 11, 12, 13, 14 and 15. Is it clear? And the process size is 4 bytes and it is divided into 2 pages. The number of pages are 2. Is it clear? Are you able to understand? Page number 0, okay, and page number 1. As it is, the process consists of 4 bytes and it is byte addressable. So you have the byte 0, byte 1, byte 2, byte 3, because always it will start from 0. So 4 bytes are there, totally 4 bytes are there. And if you see it, page size is 2 bytes. So in this page number 0, you have 2 bytes. In page number 1, you have 2 bytes. Is it clear? Are you able to understand? So totally you have 32 bytes and each frame will have 2 bytes. So totally you will have 0 byte to 31 byte. Is it clear? Are you able to understand? Is it clear for you? Now you look at here. Let's take that some of the frames are full and let me keep the page number 0 of the process here. Okay, and then page number 1 I am keeping here. You can ask me, sir, as the continuous memory is there, why you are keeping? Let's consider that all are filled except these 2 frames. So I have kept the page number 0 and page number 1. Now look at here. The page number 0 will have 0th byte and 1 byte. But when it comes to here, what bytes will be there here? If you look at here, this will be 2, 3, 4, 5, 6, 7. And here 8, 9, 10, 11, 12, 13, 14, 15. Are you able to understand? Let me erase everything and I will discuss only these 2 parts so that you will understand in a better way. So byte number 1, if I consider this is 1, 2, so this is 0th byte, this is 1 byte, this is nothing but 7th byte in the main memory. Suppose if CPU is asking the byte number 1, you should get the information which is there in the main memory of frame number 3, this byte. Are you able to understand? So this conversion who will do? The memory management unit will do. Is it clear? Suppose let's take that CPU is asking for the byte number 3. Okay, now CPU will generate byte number 3. How you can represent in 2 bits? 1 1. Am I right? Is it clear? So 1 1 is nothing but 3. How you got 1 1 as 3? You can represent like this: 1 into 2 power 0 plus 1 into 2 power 1. You will get 3. So The decimal number 3 in binary number we can represent as 1 1. So CPU is asking for the information which is there in page number 1 and page offset is 1. So it is asking for the information which is there in the page number 1 and offset 1. In this page, this one is offset 0, this is offset 1. Is it clear? Are you able to understand? So CPU is asking this one, but actually it is stored here. Are you able to understand it or not? Now how we will get it, I will discuss for you. Each process will have a page table. Remember one statement, each process will have its own page table. And the page table, let me erase this entire part. Okay. The number of entries in the page table of a particular process will be depend on number of pages. Okay. So page number 0, page number 1 in the page table. Now what this page table will consist of? It will consist of several information. One of that information is the frame number. Meaning is that page number 0 of this process in which frame you kept. You kept in the frame number 3. So it will have the frame number 3. Similarly, page number 1 of this process where in which frame you kept, in frame number 7. It will have several information. Out of that one we will also have the frame number. So each process will have its own page table and the number of entries in the page table will be equal to number of pages in the process. And each page, page number 0 where it has kept, page number 1 where it has kept, in which frame it has kept. Okay, are you able to understand? Now you look at here. CPU has generated the 1 1. It is the logical address. Now how the memory management unit will convert into its equivalent physical address, we will check it. So CPU has generated the logical address, this one. Now what it will do is that if you look at here, this is the page number and this is the page offset. So it will go to the page number 1 in the page table. This is the page table. Look at here again. The 1 1 is nothing but 1 is for the page number. So it will go for the page number 1 of the page table. What information it is there? It is there in the frame number 7. So frame number 7. Frame number 7, as the physical address in our example is 5 bits and frame offset is if it is occupying 1 bit and 4 bits will be there for the frame number. So in 4 bits, how can you represent the 7? 7 you can represent it in 4 bits as 0 1 1. So 0 1 1 you will get it. Are you able to understand? Let me repeat again. The page number is 1. So in page table it will go to the page number 1. What information is there? Frame number 7. So frame number 7 it will go, and in frame number 7 which offset you should get? Offset 1. So this information you will get it. Are you able to understand it or not? So the offset will be same. Am I right? Because whatever the offset here it is there, that same offset you will copy here. If it is 0 here, here also you will keep the 0. Only the page number will be converted into its equivalent frame number. Will be done with the help of page table. So it is going for the 0 1 1 1, which if you convert, which will be equal to what? 15. If you have a doubt, you can convert it. Let me convert it for you. 1 1 1 is nothing but 1 into 2 power 0 plus 1 into 2 to the power 1 plus 1 into 2 square plus 1 into 2 cube, which is equal to 1 plus 2 plus 4 plus 8, which is equal to 15. So you are fetching the 15th byte in the main memory. Is it clear? So it will fetch it and it will give to the CPU. Are you able to understand it or not? So I hope you have understood how the paging concept will be done with this example and what is the purpose of page table. Okay, is it clear? If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.